Hello wonderful person, this is Anton, and in this video we're going to be talking about Goldilocks stars. Stars where we could potentially find extraterrestrial intelligence and maybe even find planets that we could settle one day and create Earth 2.0. Let's talk about this and welcome to What the Math. Now you might remember a few years ago, the scientists got really excited when we've discovered the unusual TRAPPIST-1 system that had 7 different terrestrial planets, all of them actually really interesting. And although according to NASA, this is kind of what it would look like to stand on the surface of TRAPPIST-1d with some hypothetical water right there, most of the modern studies suggested that this is actually not a very hospitable star system at all. It has a tremendous amount of different radiation that would actually strip the planet of atmosphere and any chances for life to survive long term. So today, not a lot of scientists expect TRAPPIST planets to look anything like you see right here. This is the prediction from a few years ago. Today we think it's probably not like that at all. And the main reason is actually the star itself. This is known as a red dwarf or an M-type star. And even though red dwarfs are technically the longest living stars, able to survive for even trillions of years, and they are also the most common types of stars in the galaxy, they're also responsible for producing hundreds and sometimes even thousands of times more radiation that is potentially dangerous to life and the survival of atmosphere and water. Basically, they're very active in both X-ray and UV radiation and will generally turn any kind of a planet inhospitable pretty quickly. And a lot of this is actually based on our observations of the nearest star to us, which is of course Proxima Centauri, with the planet Proxima b right here in its orbit. Proxima Centauri is also an M-type or a red dwarf, but it's also what's known as a flare star. It's very active. It has a lot of really powerful flares that, if they were happening here in the solar system, would actually most likely destroy anything on Earth. Proxima Centauri is not just a red dwarf, but it's also what's known as a flare star, like so many other M-type stars as well. And a flare star creates so much radiation once in a while that it can technically destroy pretty much everything on our planet Earth or any other hypothetical planet in the orbit of the star, and would actually strip the atmosphere, destroy any kind of a life, except of course for maybe life that would survive on the dark side of these planets. These planets are almost always tidally locked, so this side here, the dark side, never really gets to see any starlight. So how do we then find an object where we could potentially find life? Well, obviously, stars like our own sun, with planets like Earth, would definitely be the best examples. But our sun, the G-type star, is actually relatively rare. Less than 10% of all of the stars in the galaxy are similar to our sun, and the biggest problem with them is that they don't actually live that long in comparison to some of the other stars. Even though in human terms 10 billion years is a really long time, remember it actually took about 4 billion years for intelligent life to develop on our planet. We know that life was originally created approximately 3.5 and possibly even 4 billion years ago, but it was only about 500 million years ago when the complex advanced life appeared. This is the Cambrian explosion. This is a topic that I've covered in one of the previous videos, and this is actually when we believe life finally started to expand, create a lot of complexity, and some of the early brains appeared as well. So in this sense, it basically takes at least 3 billion years for intelligence to start appearing on any planet. At least if we use our own star and our own planet as the only known example to us. So what about these other stars known as K-type stars? Well, it turns out, according to one of the most recent studies, these could be the so-called Goldilocks stars. In other words, stars with the most likely chance where we can discover anything related to intelligence or potential Earth 2.0, at least statistically speaking. And there are two main reasons for this. The first reason is that these stars live much longer than our own sun, anywhere from 15 to 45 billion years. They're also a lot more common than our own star, and within about 100 light years of us, if you were to look around our planet, you would discover roughly around 1,000 of these unusual stars. And this is where it gets even more interesting, because not only are they so common and not only do they live long, but they're also a lot less dangerous in terms of X-rays and UV rays and a lot of other radiation that could potentially strip a planet of atmosphere and water. They're still not as safe as our own star, but are way safer than the red dwarfs. And currently there's at least one project going on known as the Goldilocks project that tries to identify various nearby K-type stars, also known as orange dwarfs, to discover, well, first of all, how they behave, what's their rotation, for example, but overall, the discovery so far is that all of these K-type stars, such as this famous star known as Epsilon Eridani, are very likely to be the best chances for us to discover both the Earth 2.0 and of course the extraterrestrial intelligence. Now interestingly, Epsilon Eridani, along with this other star known as Tau Cetus, was originally the first ever object to be investigated under SETI. Back in 1960s, the very famous scientist Frank Drake used this telescope that you see for the so-called Project Ozma, which apparently is named after Princess Ozma from The Wizard of Oz. But during this project they investigated two of these stars for potential signals coming from the region. To be more specifically, they looked at radio signals around 1.4 GHz, which is the so-called hydrogen line, to see if anyone was trying to make a call and talk to us. But obviously we haven't discovered anything. But a much more exciting star that's not so far away from us is the very famous Kepler 442. And more specifically, the planet around this star known as Kepler 442b. So first of all, the star itself is actually what's known as an orange dwarf, and the planet is in the habitable zone of this star system. The planet is a little bit more massive and a little bit larger than Earth, so it's technically a super Earth, but nevertheless, it could easily possess habitable conditions on its surface and could actually stay like this for billions of years, which would of course increase its chances for developing complex life and possibly even intelligent life. So in that sense, Kepler 442b is a very exciting find. But one major problem with this discovery is that it's not really as close to us as some of the other planets. The distance here is over 1,000 light years away from us, so studying this planet is a little bit more difficult. But remember, there are a lot of different orange dwarfs around us. At least 1,000 within about 100 light years away from us, meaning that we're at some point going to discover more of these habitable planets around these really interesting stars. And this of course means that it's probably very fair to call these Goldilocks stars. These are probably going to be the more likely sources for us to discover various interesting planets, and most importantly, planets that can support complex life, support life for a very long time, and help intelligence develop over time as well. And since statistically there are about 100 billion different planets at least in our galaxy, that is, there's going to be a lot of various objects we're going to discover that do resemble our planet Earth in some way or another. But at the same time, it's very possible that planets around orange dwarfs could be still very different from anything we can imagine. We already know that there are so many weird planets out there. For example, the ubiquitous eyeball planets, which we think are probably the most common type of planets out there. This is something we don't have in the solar system, and we didn't really know much about these planets until we started discovering so many of them with Kepler telescope. There are also these very strange low in density planets that we refer to as super puffs or cotton candy planets, which I discussed in one of the previous videos. And some other strange and unusual objects such as mini Neptunes, which we also don't possess in the solar system. All of them are very unique, very strange, and come from different star systems. So for all we know, orange dwarfs also might possess very different planets that don't exist in the solar system. Which is of course why we need to study these exoplanets in more detail to try to understand if, well, maybe, just maybe, Earth and the solar system are just super unique. And if so, this is going to present a really big problem for us in finding anything out there. Nevertheless, at this point, at least as of 2020, the so-called habitable zone planets, such as Kepler 442b, around these stars that we can currently refer to as the Goldilocks stars, such as the orange dwarf Kepler 442, are definitely our best bet at finding anything out there. And since the previously mentioned Epsilon Eridani is the closest such star to us, we definitely need to study the star in a little bit more detail to try to discover if there are any habitable zone planets here, with some possibly even possessing liquid water and of course atmosphere and maybe even life. As of today, we've only discovered one Jupiter-like planet around it, which you can kind of see right here in Space Engine, but more studies are needed to discover other planets here as well. Our own planet Earth and our Sun are right there at a distance of just over 10 light years, so being the closest such star, this should technically be our focus for the next few years. Once we discover more about the Goldilocks stars or discover something else from this particular star system, I'll make sure to follow this up with another video. Until then, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe support this channel on Patreon because it does help me quite a lot. I'll see you tomorrow, space out, and as always, bye bye.